Hello and welcome to Nikolay's genetics lessons, and today we are going to talk about false positive and false negative. This is probability and statistical problem for medical students, and here's a problem. Hazel thinks that she may be allergic to peanuts and takes a test that gives the following results. For people that really do have allergy, the test says yes 90% of the time. For people that do not have the allergy, the test says yes 5% of the time, false positive. If 1.3% of the population have the allergy and Hazel test says yes, what are the chances that Hazel really does have the allergy? And here is a variance to choose from. As usual, I recommend you to pause video here, try to solve this problem on your own first, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. Today I want to show you how to solve this problem using forked line method. Take a look. We are told that 1.3% of the population have the allergy. So that means that 1.3% do have this allergy. And on the other hand, that means that 98.7% don't have this allergy, so don't. Now let's check our problem again. For people that really do have the allergy, the test says yes 90% of the time. So says yes 90% of the time. That means at the same time this same test would say no in 10% of the time. Again, that means that this is going to be false negative because people really do have this allergy. And on the other hand, for the people that do not have allergy, so they belong to this branch, do not have the allergy, the test says yes in 5% of the time. So this is going to be false positive. So yes 5% of the time. And that means that they actually do not have this allergy in 95% of the time. Now let's find the frequency of these four categories that we got. And the first category is going to be those people who do have allergy and tests show that they do have the allergy. So this is going to be 90% times 1.3%. So we just have to multiply these two numbers. And this is going to be 1.17%. Now let's find how many we have people who do have allergy, but due to not very accurate test, they test negative. So we call them false negative. We have to multiply 10% by 1.3%. And the frequency of this category is going to be 0.13%. This is false negative. Let me add letters here. So this is going to be true positive, and this is going to be false negative. We left with two categories. 98.7% of the population don't have this allergy, but due to test being not very accurate, 5% of this 98.7% would test positive, so would be false positive. So we have to multiply these frequencies, so 5% times 98.7%, and we are going to get 4.935%. This is going to be false positive. And the last category, 98.7% of the people who are not allergic and test show that they are not allergic. So show true results. So again, we have to multiply by 98.7% And the frequency of this category is going to be 93.765%. And this is going to be true, negative. Now let's read our question again. If 1.3% of the population have the allergy and Hazel test says yes, so she has allergy, what are the chances that Hazel really does have allergy? How many people in this population would test positive? As you see, of course, those who do have this allergy and they test positive. So true, positive. Let's circle them. And also we have those people who don't have this allergy, but due to inaccuracy of the test, they would be also tested positive, but would be false positive. Let's also circle this category. Now we have to combine these numbers in order to find how many people in this population would test positive, regardless true positive or false positive. So 1.17% plus 4.935%, and we are going to get 6.105. And this is also going to be a percent of the population who are going to test positive. But 1.17% of them are going to be true positive, and 4.935% is going to be falsely positive. Now let's read our question again. Hazel test says yes. What are the chances that Hazel really does have the allergy? So that means with our last step we have to divide 1.17, those who are true positive, because we are looking for true positive, by total number of population who test positive, and this is going to be this number, so we have to divide by 6.105, and we are going to get 19.2%, and this is going to be our answer today. Take a look, this is going to be an answer B. As you see, it is very different. This number is very different from probably many of you would think initially that if test accuracy 90% and if you test positive, then the chances that you're true positive is 90%. It is not true. As you see, the chances if you test positive, probability that you're true positive is only 19.2% due to accuracy or inaccuracy of this test. And this is all for today. Subscribe and see you in the next video. Goodbye.